we shall calculate the sum of all digits of a given number in a modified way. In the previous program, in the previous video, we have calculated the sum of all digits in this particular fashion. So now what was the logic? Taking the number from the keyboard as input, sum is equal to 0 until this n is getting exhausted. So while n is not equal to 0, extracting the last digit by doing the modulus, that is the mod of 10, adding the digit to the sum, and then discarding the last digit from the number by n is equal to n by 10. Then I'm printing the digit, then I'm printing the reduced n, then I'm printing the current sum. So we are printing d, n and sum respectively. And then after exiting from the loop, when the all numbers have got added with sum, I'm just printing the current value of sum. So that was the previous program which we discussed in the earlier video. Please watch that one because this video is in the continuation of the previous one. Now here what we shall do, here we shall do something new. Here after getting the number from the keyboard as input, I shall calculate the number of digits in the number. I shall calculate the number of digits in the number. How can I? So here I have done this particular coding with the help of which I shall calculate the number of digits in the number. What is pow? For the pow is nothing but a library function. So its corresponding prototype is defined in math.h. So that's why this math.h has to be included. Otherwise the definition will not be defined. So this pow 10 to the power of nd, initially nd is equal to 0. Let us take one number. Let it be 1, 2, 3, 4. Okay. So initially nd is equal to 0. So 10 to the power of 0 means what? 1. So 1 is less than 1, 2, 3, 4. So I am increasing the value of nd. It is while. So this process will be continued when this condition is true. So nd is getting the value 1. So 10 to the power of 1 means what? 10. 10 is lesser than 1, 2, 3, 4. nd is getting incremented to 2. 10 to the power of 2 means 100. 100 is lesser than 1, 2, 3, 4. So nd is getting incremented by 1. So it is becoming 3. So you see 10 to the power of 3, that is 1000, is less than equal to 1, 2, 3, 4. So that's why nd has got increased to 4. So 10 to the power of 4 means 10,000, which is lesser than 1, 2, 3, 4 is false. So I shall come out from the while body and nd is having the value 4, which is the number of digit in the number. So in this way, at first I shall calculate the number of digit in the number. So let me execute this part only. So I'm putting this one under comment. I'm just executing this part. Let us suppose I've given number 7689. So I should get 4 here. Yes, I'm getting 4. Let me try with 1000. I'm getting 4 here. Let me try with 723. I'm getting 3 here. So this code is working fine. So here I have calculated the number of digit in the given number. But this code can also be omitted. I'm having a better code for you to calculate the number of digit in the number. That is log 10 of n. So what is happening here? See, say log of 1000 to the base 10 is 3 because 10 cube is equal to 1000, and log of 10,000 to the base 10 is 4. So in between 1000 to 10,000 the values are ranging from 3 to 4. So now what is happening, if you take the integer part and if you go on adding 1 with it, you are getting the number of digit. If I am not getting, I can repeat here again. Log of 1000 to the base 10 is 3. So because 10 cube is equal to 1000. So you see 3 plus 1, you are getting 4 here. If you take the integer, if you do the conversion to integer, then 3 plus 1, I'm getting 4 here. Yes, 1000 is having 4 digits. In case of 10,000, so log of 10,000 to the base 10, I'm getting here 5. I'm getting here 5. So I'm getting here 4 rather. So 4 plus 1, I'm getting here 5, and 5 is the number of digits in the given number, that is 10,000. So all the numbers which will be greater than equal to 1000 and less than 10,000, they will be having the value log of n to the base 10 will be 3 point something. If you take the integer part, it will become 3. plus 1, it will become 4, and really those numbers are having 4 digits. So in this way also I can calculate the number of digits in the given number without going through the while construct. So that is a very straightforward method. I can calculate the number of digits in a number. So I'm just executing the code. I want to show you that it is working well. 1000, I'm getting 4 because 4 digits are there in 1000. So if I give the value say 10,000, so I'm getting here 5 because 10,000 is having 5 digits. So if I give a number say 7643, I'm getting 4 because 7643 is having 4 digits accordingly. Okay, so this part we have done. Now what is our aim? Our aim is that as I know the number of digits in the number, then I shall go for one for. I shall go for one for. So for will be executing for I is equal to 1 to I less than equal to nd. So in this way the for will be executing. I shall pick up the ith digit from the number without disturbing the number. In the previous program you see the number was getting exhausted, and so that when I'm getting the sum of the digits of the number has vanished because it has become 0, n has become 0. But here I do not want to make that one happen. I shall pick up the number, I shall pick up the ith digit from the number in d. That d will be added with sum, and then the sum can be printed for temporarily, and ultimately I shall print n and sum both because n is not getting reduced here and sum is having the sum of all digits of n. So in this way I can carry out. Now what is happening here, you see n is equal to 7689, let us suppose. So I is ranging from 1 to 4 because I is ranging from 1 to number of digits. Here the number of digit is equal to 4, so I will be ranging from 1 to 4. So now what I am doing is that 7689 by 10 to the power of I minus 1. What is the value of I here? That is 1. So I minus 1 means what? That is 0. 10 to the power of 0 means what? That is 1. 7689 by 1 means what? 7689. Mod of 10 means what? That is 9. Next time I is having value 2. So I minus 1 means what? That is 1. 10 to the power of 1 means that is 10. 7689 by 10 means 768.9. Integer of that, if we take the integer of that, 768 mod 10, 8. Let us come to the last one, say. So 10 to the power of 4 minus 1 means 3. 10 to the power of 3 means 1000. 7689 by 1000 means 7.689. If you take the integer part, what you are remaining with? 7. Mod of 10 means what? 7. So in this way I can pick up the ith digit from the number respectively. So what I shall do, this particular formula I'm just writing here. I'm just writing the same formula whatever I wrote here in my tracing. So that is int of n by power of 10 comma I minus 1. The whole thing will be doing the typecasting to integer and then percentage of 10. So digit will be picked up and that will be added up, and now so the current value of d is equal to this, sum is equal to this, and so on. So now let me execute my code once. So if I give the number says 7689, so at first 9 has been picked up, then 8 has been picked up, then 6 has been picked up, and 7 has been extracted. So sum was 0 initially, sum was 0 initially. So 0 plus 9, 9, 9 plus 8, 17, plus 6, 23, plus 7, 30. So you can print 7689 is having the sum of digits 30 because the number is not getting exhausted. You are not finding a single line here where I wrote n is equal to something. So whatever the value n got, that has not got updated anywhere. So as a result of that, as an end, I can print, so the sum of all digits of the number 7689 is 30. In this way, the sum of all digits of a given number has got modified with some tricky logic. Please apply this logic in the other versions of this kind of programs which will be following, and such programs will be coming in your exams also. You can apply them. Obviously don't forget to include math.h in that case. Please leave your comments below. If you are having any kind of doubts, please share with us. We shall give you the support accordingly, and thanks for watching this.